This lesson is going to be focused on the addition and subtraction of positive and negative integers, and all concepts can be applied to rational numbers as well, your decimal and fraction, positive and negative numbers. This particular concept encompasses numerous Common Core standards. And again, remember that while Common Core standards are specific to Common Core states, most states have a similar standard in Texas and whatnot, where they have a standard that covers the application and extending of understanding of addition and subtraction and how they're going to apply it to positive and negative numbers, and also understanding the additive inverse of those. And so understanding that P minus Q equals P plus a negative Q, and we're going to talk about that on the very last slide of this video, and being able to just apply properties of operations as strategies to add and subtract rational numbers. So I'm going to start out with the most basic of addition, which is just positive plus a positive. And the reason is I want it to be visually seen how we use the number line. So the very first thing that we want to do is note that we're starting at 4. So in some situations, a problem might show this happening for the very first step where it's 0 plus 4, because technically you're starting with 4. In other models, it might just start at the 4 and then have a line starting from there. But reality is that we start from 0 and we go from there. So we have 4, and what we're going to do is we're going to add on 3. So we go forward 1, 2, 3, and our answer is 7. Okay, the second one, we're starting at 2. So I'm going to show it the other way that some students might see it is where it's starting at 2, and then you're just adding 1, and the answer would be 3. So the answer going straight down from where we stop is 3. Okay, now we're going to take it the other direction, and that's negatives. So if we start at -4, so we're going to go down to -4, we stop there, and then from -4 we're going to add 3 more negatives. So we continue down this path till we get to the -7, and so our answer is -7 because we had 4 negatives and 3 more negatives, which gives us an answer of -7. The next problem is -2. So we start from 0, we end up at -2, and we're going to add a -1, and so our answer is going to be -3. So mostly in this, what I want you to see is the use of the number line helps students visually see what is occurring. Some students will show hops where it shows from 0 to -2, and then we're going to give another -1. Some students will use it that way. They'll use the number line visually that way, and that's fine because they're just showing that they're adding it. Realizing that on a test or a quiz or a state exam, they could see it as a straight bar line with an arrow where it's shown like that, and then subtracting 1. But the answer has to realize that it stops there, and so sometimes showing a ray is very confusing to a student because they see an arrow and they think, well, that arrow means it goes forever, and really it's stopping at that point, and so that can be confusing and misleading. So some of the key points that I think are very important to realize is when you're adding a positive to a positive, everything just gets more positive. So we're just increasing that number. The integer is increasing, the value is increasing, and it's all staying positive. This is what students have learned from the very beginning of kindergarten, is how to just add positive numbers. And so it's very natural for them at this point. When we jump into negatives, though, a negative plus another negative is just going to become more negative. And so while the numeric symbol that they see is getting larger, getting more negative is actually getting farther to the left from 0, and so therefore it's getting smaller. So the more negative it gets, the smaller it gets, even though that number looks larger. So for example, -10, this numeric symbol, the 10, makes it look visually like it is a larger number. But we have to realize that's like owing $10 versus if I owe $5, I'm in a better position, and so the -5 would actually be larger than the -10 with negatives. But a negative plus a negative is always going to be a negative number. Another way that we show addition is through using chips, and they like to use yellow and red chips or black and white chips. Most often I see the yellow and red chips, and red is negative, just like it is in the stock market, while yellow is the positive. So if we look at that, we think about how here on number 1 it's 4, and that's adding 3 more, 1, 2, 3, and so our total value is 1, 2, 3, 4, 5, 6, 7. And so again, many of you have seen this before, either with a younger sibling or way back when you were a child, or seeing your own child do this. So 4 plus 3 is 7, and that's just visually letting them see that in a image. And I like revisiting that when I teach positive negatives, because they remember this. They remember seeing the little circles and the dots. So when we look at the second one, where there's 2 and 1, we then see 2 plus 1 is 3. And so we get an answer of 3 for that. Okay, well with the negatives, it's really thinking about the same thing, and some students do better with chips versus the number line because they visually see it and they just get it better. So if I have red as my negatives, and I start with number 3 with -4, 1, 2, 3, 4, I have 4 negatives. I'm adding it to 3 negatives. How many total negatives do I have? I have 1, 2, 3, 4, 5, 6, and 7 negatives. And so they can see that -7 answer visually. Okay, and going to the second one, we have a -2 plus a -1, and we're left with -3. So again, we can see that that addition of just positive to positives creates more positives. Just negatives plus negatives makes more negatives. It's almost like a classification of what are we counting up, and we're counting positives or we're counting negatives. So now we take it into a real level of 7th grade math where we start looking at the positive plus a negative. So here I've got similar problems. The first one is 4 plus a -3, and in the second one I have -4 plus 3. And that's mostly to show the difference between the two. Okay, so we're going to start with the first one where we go to 4. So I'm going to use the hops where we do 1, 2, 3, 4. So this shows our plus 4. And now we're going to add 3 negatives. So when we're adding negatives, we want to go the opposite direction of what we think. When we're adding, we always go to the right on the number line, but we're adding the opposite, so we want to go the other direction. And so we see that our answer is 1. Okay, on the second one, instead we're going to have -4. So we're going to hop 1, 2, 3, 4, and this we see as being the -4 versus starting with an addition of -4. even though it's basically the same thing as adding negative 4. So now we're going to add 3, and I'm just going to change my color just so that we can see it a little bit better. So adding 3, we know we go to the right. And so when we added 3, we ended up at a negative 1. So what relationship do we see between the 4 plus the negative 3 and the negative 4 plus the 3? One thing that we should know is that when we have opposite signs, we're finding the difference of the two values. So 4 minus 3 is 1. In both cases, the solution has an absolute value of 1. But one is positive, one's going to be negative in its actual answer. So if we continue to look further, we see that in question 1, there were more positives when we started. There were 4 positives, but 3 negatives. And so while our difference is 1, we have 1 positive left over. Okay. In the second one, though, we see that the larger is our negatives. So when we find that difference, we see that 4 minus 3 is 1, but what's left over is a negative 1. And so how I like to explain this to students is that we have negatives plus positives. When we do that, we cancel them out. And whatever is left over is our answer. So, for example, if we had we're going to just draw in, I like to call them bad guys and good guys sometimes, but cops and robbers, I don't know. But you have 4 of one, and then you've got 3 of the other, and so people could even think of it as pairing up or something. So if these are paired up, so say it's a cop and a robber, well, the one cop and the robber are, the one cop's arresting the one robber, the next cop is arresting another robber, and the next cop is arresting another robber. Well, what's left over? We have 1 robber left over, and that's why we have a negative 1 answer. And sometimes that visualization, that storyline helps students, even though it's not the most creative of storylines out there. Okay, so how does this look in chips? With positive and negatives, I actually find the chips are easier to work with versus the number line, and that's partially because they can see that pairing up visually, kind of like the little stick figures I drew on the last screen. So we have 4. I'm going to change my color size. There we go. We got 4 positives. And when we add, we're just combining. It's almost like cooking. You're just throwing everything into a bowl or a pan. So we're just going to put them all next to each other. So in this case, we've got 3 negatives. 1, 2, and 3. Now, when we think about what's happening, we have positives and we have negatives. And a positive and a negative cancel themselves out. And we call these 0 pairs. A positive and a negative, they cancel each other out. It's like saying, here's 1, nope, never mind, I'm not giving you 1. And so nothing was given. So when we look at this, we can say, well, here's a 0 pair, they're paired up, that one's paired up. What are we left with? We're left with 1 positive. And so our answer is 1. When we look at the second problem, we're starting out with 4 negatives, 1, 2, 3, and 4, and we're adding 3 positives, 1, 2, 3. So here, there's a 0 pair, there's a 0 pair, and there's a 0 pair. And so what we're left with is the answer negative 1 as our solution. So why do we call them 0 pairs? I just want to remind you that what I said a second ago. If we have a plus 1 and a minus 1, that equals 0. And so that's why we call them 0 pairs. They cancel each other out. Okay, so we've done addition. Now we're going to jump over to subtraction. And with subtraction, you think about that you're removing from the first number. So there's a value given to you, and then you're subtracting from that. You're removing from that. So if you remove more than what you originally started with, you would end up with a negative answer. And that's important to think about. Is it's like going to somebody and saying, well, I want to take 3, but that person only has 2. Well, they're short 1. They're -1 of the 3 that they need to have to give you. So we're going to look at this first problem. We're going to start out with 4, and this is a regular math problem that a student in first grade would see, or kindergarten. And so they see 0, 1, 2, 3, 4. They start with 4. They're then going to subtract 3. So when they subtract, they go back 1, 2, 3, and they see that their answer is 1. And I'm going to immediately go to the chips on this, so we're going to kind of go back and forth with that. So here I've got 4 positives. And with subtraction, we're taking away. So we tell students subtraction, take away, minus, all different ways that we've told students how to subtract. So I'm going to visually show that as we're going to mark through them. So 1, 2, 3, and what am I left with? I'm left with 1. Okay, so going back to the previous screen again, now we're going to go to our next problem. Our next problem says 2 minus 1. So we're going to hop to 2, and then we're going to subtract 1. And we can see that our answer is 1. Moving back to the chips, if I start out with 2, 1, 2, but I take away 1, my answer ends up being 1 as well. So you can see the relationship between the number line and the chips, and this is a concept that we teach students in kindergarten, first grade, second grade, third grade, and then when they get up into the middle school level math, and we're teaching negatives and positives, we're able to relate that information, spiral back on that knowledge they've seen before. So again, remember that we're removing from the first number. And if you try to remove more than the original, then you're going to have a negative answer. Now we're going to jump into if I have a negative and a positive, and what does that look like? And a lot of students struggle with this because of the fact that they start out with a -4 and then they subtract 3 positives and they immediately want to say that the answer is 1. Because they think about how they're subtracting, so it should be -1, right? No, it's not -1. Because if I said 0 minus 3, what is the answer? A student would tell me -3, but for whatever reason, when we start out with a negative, it's hard to visualize that concept that we have 4 negatives and we're going to have 3 more negatives, or that we have 4 negatives and we're subtracting 3 positives, and if we get rid of positive, we get more negative. So displaying that information, showing that information, explaining that can often be very confusing to students. So here's what it looks like on the number line. They see it as subtraction. Subtraction is to go left on the number line. So they go to 4 and they're at 4. Now, if they think of it as subtraction of 3, then they would continue to go left on the number line. And they're going to end up at -7. Okay, let's look at the second one. We're going to start out going to -2. So we're at -2, and now we're going to subtract 5. And subtracting means to go left. So we're going to go 1, 2, 3, 4, 5. And we can see here we end up at -7 as well. So again, remember, when you subtract, you move to the left on the number line, even if you start with a negative number. It doesn't matter, you're still going to the left. So now we're going to bring in the double negative, just to add a little bit more excitement to this. So we're going to start out on number 1, and we're going to follow the same idea that we were doing. So we're going to draw a line from 0 to -4, and that's showing our -4 happening. But this double negative is telling you to reverse it. It's like saying, don't subtract. Okay, double negative, the not nots. In ELA, we always think of it as a double negative means that's not what's really happening. And in math, it's very similar. Don't subtract. You're not subtracting. That double negative is saying don't do it. But if you think about it, if you're going to subtract, you're subtracting negative. So what are you subtracting? And if you're getting rid of negatives, then you have to get more positive. So we have to reverse that and go back. And where we end up at is the -1. So 4 minus -3 is -1, because what did we subtract? We subtracted 3 of those negatives from the -4. Okay, so in words, it's -4 minus -3. And sometimes that makes it more visual as to how we end up at -1. Looking at the next one, we're going to start out with -2. So we go to -2. And what are we subtracting? We're subtracting -5. So when we do that, we're going the opposite direction. That double negative is going to take us the opposite direction. So we're going to go 1, 2, 3, 4, 5, and we're going to end up at a +3. So at the bottom, I put, think of a double negative as if you are saying not subtraction. Because if you thought about it as not subtraction, you thought -2 plus 5, you're going to think differently, because we're going to go back to that prior knowledge where I said when you have an addition problem of positives and negatives, they cancel each other out, and whatever has some left over is going to be your solution. Okay, so we've covered number line strategies, and we've covered chip strategies, and with subtraction we've pretty much only shown the number line strategy. Another strategy is to use an algorithm called add the opposite, and in order to add the opposite you have to understand that inverse characteristic of that when you are doing the opposite operation, you're also doing the opposite information with the particular integer. For example, if you're adding 4, it's the same thing as subtracting -4. But if you're subtracting 3, it's the same thing as adding 3 negatives. And so being able to visualize that opposition of +3 is one thing, but if you're subtracting 3, it's the same thing as adding -3. So what we don't realize is when we have subtraction, we have a little tiny plus sign in front of that 3 that we don't think about. When you're saying, well, we're subtracting and we're just subtracting something. But really what we're doing is we're subtracting positives. And so knowing that and being able to understand that this is the inverse operation with the inverse sign in front of the number does help, and it creates that integer inverse operation. So if we use the add the opposite strategy, we have to change 2 things. So here we're going to take 5, and now we're going to add the opposite of this 2. Well, the opposite of this 2 would be a -2. When we're adding things that are opposite signs, we cancel them out. So there's 3 left over. There were 3 positives left over, so your answer is 3. I'm just going to put the positive in front of there so that you think about it as it being what it really is. It is a +5. Okay, if we go to the next one, we have -5 minus 2. So we have -5. I'm going to add the opposite. So we thought of it as having a positive right in front of that 2. And then we realized, oh, okay, well, if we add the opposite, now we're saying -5 plus -2. And that equals -7. If you remember on the number line, if we started at -5, subtraction meant to go to the left, and so you'd end up at -7 as well on the number line. You're continuing to go left. Okay, on this next one we have our double negative. So the 5 is currently positive. We're going to keep that. We have a subtraction sign. The subtraction is going to become the opposite. We're going to add. And then here we have a negative 2, and the opposite of negative 2 is a positive 2. And so remember when I said double negative means to do the opposite. We are not subtracting, we are adding. And so we can see that's actually 5 plus 2, which is 7. Okay, looking at another example of it, we have our negative 5. So we're starting out negative already, but we're going to add the opposite. So we had a negative 2, it became a positive 2. We had subtraction, it became addition. We added the opposite. If I have 5 negatives and 2 positives, and they pair up and cancel each other out, we are left with negative 3. This concludes this lesson. If you have any questions, please reach out and let me know. Thanks so much.